It's another beautiful day that we gather this equation, as you can see on our screen. And this equation is integral of x raised to the power 4 all over 1 plus x raised to the power x dx. And we're supposed to integrate this. Yeah, after a thorough discussion with the student, we decided to come to consensus and solve the question together, because after I've realized that a lot of them I realized that a lot of them were fumbling. Okay, you see, even me, I'm fumbling at the moment, can't talk straight. Okay, so most of them were finding it very difficult to break it down, so I decided to break it down so that everybody can understand how this can be done with ease. Well, I'm telling you, I can drop this one in the exams and I wouldn't change any parameters and it's still people fumble. Anyway, without further ado, let's set the ball rolling. Okay, so in the first place, this is the integration we have. So let's go here, then I will pick this. Okay, so we have this. Good. And so that's what we have. It says the integral of x raised to the power 4, x raised to the power 4, turn it very well. The integral of x raised to the power 4 all over 1 plus x raised to the power 6 into bracket dx. So we're supposed to integrate this. If I look at this one very first, the first attempt, somebody will say, okay, why don't you, somebody may say, why don't you use substitution straight away? Why don't we use the substitution right away? Well, if you look at it, if we say we want to use substitution, we'll find ourselves fumbling. So I think if we look at it very well, something comes into the mind that if we square the integration, I think it will be easier for us to do further, maybe trigonometry approach or something. So let's try and see. Let's square the integration. So let's square the integration. So if we square the integration, then as you can see, our integral is going to be integral x raised to the power 4 all over x 1 plus x raised to the power 6 all squared dx. Okay, if we integrate, if we look at the integration very well, you see after expansion, you see we are going to get x raised to the power 8 and all into bracket. I can see 1 plus s cubed, okay, squared here, all squared dx. You see, you can see that I have intentionally, splitted the x raised to the power 6 to be s cubed in here, if you can see. Okay, if you can see over here, there's a trick for that reason. So there's a trick for that reason. Why is it so? We will see it as we go along. So first and foremost, all what we've done is to square the whole integration, and when we square x to the power 4, we have x to the power 8 and 1. Okay, that's 1 plus x to the power 6 is 1 plus into bracket s cubed squared, all squared. Well, let's see. Let's say, let's make a substitution. So our assumption, okay, is let's the s squared, let s squared, okay, now let's see this one over here. Let s cube equals to tan of theta. You see, when you do that, and we differentiate this, okay, that will help us to do something. So we're going to differentiate this. Okay, we're going to differentiate. This equation. Okay, so when we differentiate this equation, then we are going to go get d of s cubed and d of tan theta, which eventually will give us 3s squared dx is equals to sec square theta d theta. Isn't that beautiful? So through this equation, then we can derive our dx to be equals to sec squared theta d theta all over 3x. So I'm going to highlight this because we're gonna make use of it very soon. So this is our ds. Okay, eventually it will help us to do a certain substitution. So if that is the case, then let's substitute everything back. So now we can substitute this and that into the equation to make life easier. Okay, so when we do that, then we're going to have the integral x raised to the power 8 all plus 1 plus tan squared theta, okay, all raised to the power 2. So you see that what I've done is, where is s cubed here, I've substituted the tan in the place of the s cube. So I have this, so multiplying by dx, and my dx is sec squared theta over 3s squared d theta. So you see that there's going to be some cancellation. Okay, there's going to be some cancellation. So our cancellation, let me write here, is integral, yeah, x raised to the power 6 all over 1 plus tan squared theta all squared times sec squared theta all over 3 d theta. Why is it so? Because, let me use this one to demarcate. If I use the green, okay, you see that this will cancel this, and it will be left to x to the power 6. This s squared will cancel x to the power 8. That meaning s squared, x8 divided by s squared. So this will leave us with this equation, which we can further write it down. Okay, write it down as this, as we think. So the next is our equation. We have the equation now. Okay, so the next step will be, let's simplify this further. Let's break 1/3 out. then integral, this will become, you see that since we have s raised to the power 6, it means we have s cubed squared all over 1 plus tan squared theta, okay, all squared, multiplying sec squared theta d theta over 3, when we move the 3, the theta. Okay, so 3 is out. Now, this we can further write it as 1. You see now that let's substitute, let's put x to be equals to our substitution to be s cubed to be equals to tan theta into this equation. Okay, so we're going to substitute this one back to this equation to give us another simplification. Okay, so our simplified form will be 1/3 integral tan, well, this one will be this one will be tan all squared over to bracket 1 plus tan theta squared multiplying by our sec square theta d theta. So you see that all what we're doing is just simplifying the equation, breaking it down. Okay, let me write here a bit. So the next step, we still have 1/3. Let me write it. Well, 1/3, and a tan theta squared over here. So when we expand finally, we are going to get tan clean this. We are going to, okay, so we are going to get tan square theta all over sec square theta times sec square theta d theta. So this we can write as 1/3 the integral of tan square theta all over what? Sec squared. But here, since this one is sec squared 4 theta, let me write it well. So this sec squared 4 theta. So this is sec squared. Oh, sorry. Okay. So our is sec squared 4 theta. So obviously you see that there's going to be a cancellation once again. We're going to cancel, this one's going to cancel this. Such a way that we have tan squared over sec squared theta. So we have sec squared theta, sec squared theta d theta. Okay, so that's what we've got at the moment. So you see, we have broken the equation down to a certain point that this is what we have at the moment. And we all know that when we have tan squared theta, it's always given as sec squared theta minus 1, okay, from Pythagoras theorem. So with that, we're going to substitute this into this equation. Our final equation, we are going to substitute this equation into this. So when we do that, okay, then it's going to be 1/3 integral sec squared theta minus 1 all over sec squared theta, sec squared theta d theta. Well, so this, we can handle it. We can handle this integration. Why am I saying that? Because we can do something we call expansion. Okay, so when we separate the integral, okay, then this will be 1/3 integral, okay, sec squared theta over sec squared theta, then minus 1/3 integral, this will be 1 over sec squared theta. You see, so all this d theta, and we know for sure this will cancel each other, so that our integral now is going to be 1/3 integral d theta minus 1/3. We know 1 over sec squared is always given as cos squared, so this will cos squared theta d theta. Okay, so beautiful thing. You see, we've broken the integral down totally. Okay, now let me take a sip of water. So with that, you see, if we integrate our thing, if we integrate everything over here, we are going to get, you know, when you expand this, it will help us to break it down further. But this is cos squared theta. So then, when we integrate everything, we are going to get 1/3 out. You see, this one, the theta, when we integrate, will be theta. And this will be minus half theta minus half sine theta cos theta. Beautiful. So this is our integration. But we can simplify it further. So this will be 1/3 into bracket theta over 2 minus half sine theta cos theta. Okay, this is looking beautiful, but we haven't finished. But because we know that our triangle, this, if we consider the triangle, then we say that theta is, if you use SOHCAHTOA, we know our expression s cubed is equals to what? Tan theta. Okay, means this is divisible by 1. So if that is the case, okay, if that is the case, if the substitution that we did is divisible by 1, then we can say that twa is opposite of adjacent. So this s cubed used to be 1, yeah, 1. And when we simplify, we get here to be, when we use the particular theorem, we're going to get the r over here to be r squared is equals to 1 squared plus s cubed squared, which now will give us 1 plus x to the power 6 squared. So the square root of this is square root of 1 plus x raised to the power 6. So that's r over here. So if we use this to resolve for our sine and cosine, we're going to get a cos theta to be equals to 1 over square root of 1 plus raised to the power 6, okay, or square root. Then our sine theta will be equals to x cubed over square root of 1 plus x raised to the power 6. So when we substitute this into this equation over here, Okay, then definitely now we know that this very equation, we can also write it as theta over 6 minus 1 over 6 sine theta cos theta. So when we substitute this one into this equation, we are going to get, since we know theta, we know that s cubed is equal to tan theta. Okay, and definitely if s cubed is equal to tan theta, then our theta is equal to what? Tan inverse of s cubed. Okay, so where we see theta, like here, is going to be tan inverse of s cubed over 6, and there's 1 minus 6 multiplying the sine, which is s cubed, all over square root 1 plus 6. So there 1 to the power 6, and this multiplying 1 over square root 1 plus this. Yeah, beautiful. So with that, when we simplify further, our equation now will be 1/6 tan inverse of s cubed minus s cubed all over square root of 1 plus x raised to the power 6. This is our answer. Beautiful. It's not beautiful? Plus constant c. So this implies that this equation, the integral, all x raised to the power 4 over 1 plus x raised to the power 6 dx is giving us 1 over 6 tan inverse of s cubed minus s cubed all over 1 plus x raised to the power 6 plus our constant. So this is the solution that we have been able to attain. It's beautiful. It looks like it's a long to come, but well, I don't think it's not anything complicated. So let's go up and recap. Okay, so we see that this is not anything to be scared of at all. So what I started by saying, that why don't we use the use substitution right away? But using the use substitution was going to make the equation very complicated. So we decided to substitute x values in a certain way that it was going to give us a problem. So now final decision was to square the integration. And when we square the integration, we ended up with this. Yeah, we ended up with this. With this, okay. We ended up with this. Okay. So this was our equation we attained. Okay. 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 So with this, then we know that we say assumption is let x cubed to be equal to tan theta. And we substituted this here into our equation. So you see 1 plus x cubed raised to the power 2. Okay, also come down all the way to x raised to the power 6. So we haven't changed anything. All what we did was we expanded. Okay, so that x cubed raised to the power 2 will give us x raised to the power 6. So by substituting this into the equation, okay, was going to help us to make life easier for us. So as we differentiated this expression, we have free s squared is equal to z squared d theta. That we made change of subject here. Okay, change of subject, and we had dx to be equal to z squared d theta over 3x squared. Then we substituted this, the x, into the equation. Then we came to this point. Okay, now over here we have x raised to the power 8 all divided by 1 plus tan squared theta, which we have substituted, all raised to the power squared. If that is the case, then our trickiness has gone down, because we know that x squared over here, cancel the x with the power 8, so we have x with the power 6, all over 1 plus tan squared theta, all to the power squared. Then multiply by the sec squared theta over 3 d theta. We brought 1 over 3 out to make life easier. Okay, then we put here, we put this equation straight into it again. Then we came down here. Okay, then we say 1/3. Okay, this is tan all squared. Okay, and that straightforward we know is tan squared that to that, and we'll simplify. We have tan squared theta over sec squared 4 raised to the power 4 theta multiplied by sec squared d theta. Okay, now here we brought the 1/3 out, so eventually we had tan squared theta over sec squared theta d theta. Okay, but we know for sure that tan squared theta is equal to sec squared theta minus 1. That's from the Pythagoras and in trigonometry. So then we substituted this back into this equation. Okay, after getting this equation, okay, that was easy for us to handle. We did a bit of separation of integration. Our separation is, now we say let 1/3 and sec squared theta over sec squared theta to come on one side, and this one come to one side. Now we realize that this, so we have the theta here, we shouldn't forget. This divided by this to be 1. So we say 1 d theta, we don't write it 1. So we say 1/3 d theta minus 1 over 3 cos squared theta d theta, because 1 over sec squared theta is 1 over the reciprocal of 1 over cos squared theta. So that change it to be cos squared theta. Now, after that, then our integration becomes so easy for us to do. Okay, so integration now becomes so easy. If you look at it, this is the integration. That's how we did it. Okay, so this is the integration part. Okay, we brought the 3 out, we integrated it. Okay, we have this, and so theta minus half theta give us theta. Okay, over 2 minus an integral of that give us minus half sine theta cos theta. Now bear in mind, the one we started, we said let x cubed to be equals to x cubed to be equals to tan theta, but we know that the x cubed standard alone means it's divisible by 1. So then we use Pythagoras theorem to deduce the values for the hypotenuse to be that. Okay, so by substitution back into the equation, we're able to generate the values for cos theta and sin theta. And we substituted this back into this equation, our final equation. Okay, this is the final integral. So when we integrated everything, this is what we had. But we should also bear in mind that our answer that we're supposed to get was supposed to be in terms of x, but not theta alone. So, but we did a back substitution of this ones, okay, into the equation, this equation here, okay, into this equation, and this one became, since we know theta to be tan inverse of x cubed, we put it in the equation, minus half over 6 multiplied by sine, and we know sine is here. There's a value for sine. Okay, then after that, we know this is cos and this is cos. That's cos. So we substituted this ones into the equation, and this is what we achieved. Upon further simplification, we arrived at 1/6 tan inverse of x cubed minus x cubed all over square root of 1 plus x raised to the power 6 plus c. So this is what we achieved. So this is a final result. Okay, well, you can take your time. Chaps, take your time and break it down. You see that you can do this with ease. So this is what we get at the end of the day. Well, thank you very much once again. But I will urge on to subscribe to this channel and also, send it out to your friends and like the videos. Okay, so that we will be energized to decide to do more. Thank you very much once again, and looking forward to see you again. It's been very crucial tonight. Thank you very much. Looking forward to see you again. It's been very crucial tonight. Thank you very much. Bless you. Bye.